Hello, everyone, and thank you for joining our session on the Radio Intelligent Controller at the Open Networking and Edge Summit of the Linux Foundation. I'm Constantine Polychronopoulos with Juniper, and I'm pleased to introduce Francisco, better known as Paco Martin Pignatelli. Paco is a Vodafone executive with more than 22 years of experience in every aspect of the network, having served as a key driver on the radio, on the core, on the transport, also in various capacities. However, over the last almost 5-6 years, Paco has been one of the leaders of open radio access networks, the ORAN Alliance, major contributor, and heading the Vodafone activities in that respect. So we're very pleased to have Paco here, who will share with us Vodafone's plans, thoughts, and projections about ORAN and in 5G and not only. Thank you, Paco. Over to you.
Thank you, Constantine. Yes, it's Paco Martin here. I'm head of Open RAN in Vodafone. It used to be radio product, but we recently decided to change the name from radio product to Open RAN, because our vision is that all the radio will be open. So we are working on that. We started actually this project about 5 years ago, initially focused on just cost, but then this opportunity of radio intelligent controller came up, so extending the scope. Looking forward to having the conversation here.
Thank you, Paco. So in this session, we're going to have Paco present again Vodafone's plans and activities around the radio intelligent controller. That will be followed by Juniper's introduction of the radio intelligent controller and our activities in ORAN. The session will be followed by a few questions that we're going to ask Paco and see where Vodafone is heading in this very important segment of 5G. Paco, please go ahead with your presentation.
Thank you, Constantine. So first point to note is that when we started Open RAN, there were a few areas that were the initial target. First of all, there was an idea of changing the ecosystem and making sure that there was a model, a way to do radio that was different from before, that wasn't including some of the problems of traditional radio, including a vendor lock-in, the fact that you deploy a network with a supplier and then it's difficult to change that supplier. So that was one of the ideas, as well as enriching the ecosystem with multiple suppliers. We also thought that the Open RAN model could be a way to boost innovation, initially focused on cost. So we have a number of initiatives around white box solutions and around improving the radio, including the baseband, including common off-the-shelf hardware. Those are targeted technology evolutions, but we somehow had also in mind the opportunity of doing something different, a new architecture. And that is what is the topic for conversation today. The main one is a radio intelligent controller and what it can mean for Vodafone and for the overall industry as a main change. We have this chart that shows the traditional way of doing things, and then the new architecture that it's been put forward by ORAN, where we have the chance of building a platform in the same way as we had in mobile systems, for example, with the OSS from Apple or from Android. Then you can build on top those applications that can run either in real time or in near real time, delivering a service, delivering the possibility to tailor your radio service in different ways. So this opportunity increases on one hand the potential for new revenue, but at the same time gives you the flexibility and another way of getting efficiencies thanks to your applications, and that's something we're going to be discussing later. If we look at the evolution, well, how do we think things are going to be unfolding? We had some in the network, in the mobile network, about 5 years ago. So it's now implemented everywhere. Things like anomaly detections or ANR or basic optimization done in an automatic way. The first path for radio intelligent control applications is somehow replicating those functionalities, but implemented in the RIG platform. And we are already there. Actually, I think we are already moving into the next one, which is more about being able to use in real time some of the resource management, radio resource management system and functionalities we have in the radio. So being able to handle in real time traffic steering or enhancing multi-user MIMO, informing. We are, I think, at that level now in terms of algorithms that we know are going to work. Those will be ported in form of applications on this RIG platform. But ultimately, the opportunity for RIG can come thanks to applications tailored to specific industries or specific functionalities, specific areas. For example, well, energy saving can be one of them. But if we think about the opportunity for different industries, we can have, imagine a company in the automotive sector, and imagine a player that is normally not in the software of the radio, like one of those big companies, Accenture or Capgemini or some of those. They know the automotive sector very well. They know how to do programming. Thanks to the standard of RIG and ORAN, you know how to build applications. Then you can capture the opportunity. You know your customer, you know what they require, you know how to build software, then you do it. So that's kind of the opportunity eventually, where the different new players will come in and will play in an area that was captive before, that was not available for everybody. This is going to take some time. We know that RIG is still standardized, but we are pretty sure that this is the journey. So hopefully in a couple of years from now, we'll see those applications starting to flourish, and the opportunity will start to be captured. It's important as well that we as an industry, we push and we set the right framework for everything. So apart from preparing the opportunity, you need to be able to take it forward. You need to be able to evolve it, and I think we have two main actors here in the area of specifications and taking things to market. One is the ORAN Alliance, that is defining in working group 2 and working group 3 how RIG should be working, and then we have also the telecom infra project with the radio intelligence and automation group that's working on making this happen. It's working on developing the applications and defining the use cases and enabling the first opportunity. So we now need more companies stepping in and preparing some initial applications and trialing them and then making this happen. But I think the ground is already prepared, and as we progress in the standardization, then things will start to happen. But we know that there are some challenges to this. So one comes in the way of specifications. So we need to make sure we run fast in this cycle of defining a specification, testing, finding issues, feeding that back into the original specification work. All this needs to happen faster, as it needs to happen that we certify the initial solutions and that we prove that things can work. Open Run is just it's a nascent ecosystem. We obviously need to accelerate the implementation in the traditional radio of this opportunity. Some of the big radio suppliers are already embracing RIC, so that's fantastic news. Probably they will have a very, very important role to play to make it successful, but it's important that they come into Open Run ultimately, but in particular in this RIC space, where for sure they will be very valuable contributors from day one. And as we evolve into a new architecture, not only restricted to RIC, but overall in general, we need to make sure that we are covering all the security aspects. So that's obviously one of the challenges and one of the key areas that we have to focus on. And obviously, one of the key points of focus is how do we ensure that this system can work. And for example, I mean, we can all picture in our head the challenge of having multiple applications accessing at the same time in very real time to something like the radio scheduler. How do you handle those requests when it's multiple applications that want to have access at the same time to this very, very sensitive part of our radio? So there are some technical challenges we need to tackle, but we know what those are, and we know that we need to start developing and deploying rigs so that we fix them as we encounter them. We have covered the opportunity, but the reality is that we are already there doing some of the initial steps in the journey for RIC. We are happy to be already trialing our first implementation with Juniper in Turkey and Parallel Wireless. This is a solution that fits somehow with what I was saying before, that it's a self-optimizing network functionalities now implemented in RIC, because we're talking about 4G admission control here, but it's a very important proof point for the overall platform, and it's a very important step to make sure that we can run this type of system on a commercial environment. We have to go through standardization, but the journey has started. In particular, we are, I think, a little bit even more ahead in the journey than that, because we have already tried and tested in our labs another system that includes other suppliers, some big ones like VMware, Intel, or Capgemini, and also Cohere, who are providing algorithms already that can be integrated into RIC applications. In the case of Cohere, is helping us to improve capacity thanks to a better channel estimation. And in the future, we know that we can even improve the system much more, and we have some cool ideas out there. So, for example, imagine imagine what happens with a car. You get it that is tuned to some generic settings, but we know that we can modify them and get more power out of it, or get more speed out of it. Similar thing can be done with the hardware. So you could run some radio intelligent controller applications on top of your hardware and get a modified version, a modified performance for that hardware, depending on what you want. Be it the energy or more energy efficiency or different radio performance. So we are willing to do that as well, and it's a bit of a long shot, but we're starting to work on those type of applications. So we fully capture the opportunity for RIC. This is my presentation today. I hope you liked it, and looking forward to questions and the presentation from Constantine. Thank you.
Again, thank you very much, Paco, for the forward-looking, inspiring presentation. It's great to see where Vodafone is heading and share your thoughts. We're going to switch and give a view now. We'll continue basically, on the radio intelligent controller, and I will give a summary of the activities we have, the solutions we have built at Juniper on the radio intelligent controller and ORAN, and share some of the thoughts that go beyond the trial at Vodafone with parallel wireless and Juniper. So again, as Paco outlined, we are already engaged in a trial at Vodafone in a multi-vendor setup where we partner with parallel wireless, which provides the virtualized BBU, the H and G gateway and the EMS, and is fully integrated with the Juniper near real-time and non-near real-time RIC. The initial focus is going to be select xApps, specifically admission control, which works not just in 5G, but we're going to demonstrate here the ability to do so in a 4G network. That's exactly what we're doing at Vodafone. And in principle, as long as a virtualized radio can provide the necessary PMs and the necessary interfaces, either ORAN E2 interfaces or even proprietary interfaces, a radio intelligent controller, a RIC, can bring the benefits of management of the radio resources, dynamic management, to pretty much any virtualized, any software-driven radio, even though the focus is primarily on 5G. So that's exactly what we're demonstrating at Vodafone in partnership with Parallel Wireless and Juniper. But let me take a step back and look at the radio intelligent controller in a more, general way. If we really think where we were up until 4G, where the radio was built out of proprietary appliances, and it was extremely difficult to upgrade the radio. Sometimes you had to really, lift physical boxes out of the, radio sites and do upgrades or replacement, etc. All that is the old way of doing business, right? As we move to fully software-defined radios driven by the ORAN architecture, now we have the possibility of truly programmatically defined use cases on the radio without having to touch any physical resource. I like to use the analogy of operating systems to CPUs, right? So I call, the RIC is to the RAN what the operating system is to the CPU. If we really think about it, that's exactly the right type of analogy. Or the hypervisor to the virtual machine, right? The radio intelligent controller essentially opens up the radio to applications and provides the means to manage low-level radio resources, to allocate them across different users, across different devices, and manage the way the spectrum is shared among competing use cases. A very powerful paradigm that allows us now to build new applications that can come in the form of SON as an xApp running on the near real-time RIC, as well as applications that are AI, ML driven, and leverage historical trends in the network to provision radio resources ahead of time as the need arises. In addition to that, of course, applications like load balancing, traffic steering, massive MIMO, etc. We'll talk about other possibilities for xApps, bring new value to the radio, new ways of managing the radio, and therefore building applications that not only drive optimization, new ways of addressing optimization in the radio, but also opens up the possibility for new business models that drive revenue generation as well. So it's really the new way of thinking about the radio as well as the rest of the resources in a software-centric, software-driven approach. We have managed to do so across the entire infrastructure. The radio was the last bastion, and Oran enables us now to really bring software-driven architectures to the most critical component of 5G, and not only 5G. At Juniper, of course, we're building not just the platform, we're addressing also key aspects of the architecture that have to do with the way xApps potentially can interfere with each other, trying to manage or reconfigure the same type of resource. We address those, we address the mitigation. So we enable third-party applications also to run on our RIC, leveraging our SDK that exposes common PMs to xApps, for example, addresses conflict resolution and mitigation, and provides a very flexible way of sharing PMs in the database performance, key performance indicators across different xApps. So certifying xApps as well as addressing conflict resolution are key components of the platform. On top of that, we're building a host of xApps in partnership with other technology companies, as well as homegrown within Juniper in partnership with our customer operators. And these are, these fall in three large buckets: the personalized service experience type of xApps and our apps, revenue stream generating xApps, opening up new business models, as well as CapEx and OpEx reduction. I like very much what Paco presented in the use cases, where his position was that the RIC enables now domain expert entities to build their own xApps. He used the example, if I recall, of Accenture or Capgemini, for example, that have a lot of expertise on the automobile industry, right? To leverage the RIC to build domain-specific xApps that will be, needed down the path by that segment of the industry. And we can repeat the same concept across different industry verticals, enterprise verticals. So a very powerful model. Now, perhaps the most complex, and in my view and the view of many, the most complex xApp and our app is the one that drives network slicing. And what is network slicing? By now, everybody knows. Taking essentially today's networks that look at everything in the same way, every device, every use case is treated in exactly the same way, one size fits all, to where network slicing is going to take us, where the network provides specialized SLAs and even applications to each different device, different use case, different user for that matter, right? So the notion of network slicing allows us to build now essentially purpose-built networks that address specific use cases on the same physical infrastructure. A very powerful model that enables not only the industry 4.0 use cases, but also opens up the possibility to potentially offer private mobile networks through the operator infrastructure as well. We'll talk a bit more about that. So if we look at network slicing, one of the critical components is the ability to bring up a network slice in an end-to-end fashion. So the radio is the most complex use case, of course, and the one that was elusive so far because it was closed. Oran opens up the radio intelligent controller, enables now any application to access even resource management hooks into the radio and tailor them to the needs of the application. And of course, the RIC is the arbitrator of how resources are shared dynamically across different tenancies, different slices. In doing so, of course, the RAN domain orchestrator is the critical component that brings up not only the infrastructure, but leveraging the near real-time RIC and the non-real-time RIC can build, again, use case specific slices. And given that the RIC has global view of the radio resources and the use of the radio resource at any given time, it also has the ability to do things that are not possible without the radio intelligent controller. For example, we can build an end-to-end slice that has dedicated view, right? Since we have now visibility of all the distributed units in the radio in an ORAN architecture, we can dedicate DU, for example, that share potentially the same radio with, on a specific slice, and have other DUs that are shared across different slices. We see an example here. The orchestration and the stitching together of all the data plane components in a way that addresses the network slice specific requirements from the SLA point of view is key, in enabling network slicing end-to-end. And of course, placement of the data plane components like the DU, the CU, user plane CU is again dependent on the requirements, the performance requirements of each particular slice. All of that again is possible through the RIC, but is enabled by the RAN domain orchestrator. As we place the components, the functional components, the next question is how do you connect them together, right? So the RAN orchestrator has to work with the transport domain orchestrator to be able to provide the appropriate connectivity and address also the necessary SLA requirements to build the end-to-end use case. And Juniper focuses, this is one of our main differentiators, leveraging the Juniper strengths on the transport domain to be able to deliver an SLA along with the orchestrating a network slice across not just the ORAN domain, but across the transport, the WAN connectivity, as well as the data center. This is a simple use case that relates to admission control, where the non-real-time RIC coordinates with the real-time RIC to orchestrate different slices and manage resources, PDU, allocated PDUs in this case on a per slice basis dynamically. The example we use is 3 slices. One is dedicated to general use case. Another one, let's say, can be dedicated to a hospital with 200 PDU sessions allocated to that use case, or another slice that is used by a school with up to 100 PDU sessions. Now, the school may not use all the PDU sessions over a weekend, right? So the RIC provides the flexibility of reallocating those PDUs to another use case that maybe over the weekend may have another slice that may have more requirements, right? More importantly, this can be done dynamically. An emergency use case, which requires the hospital to have more access to the network, more PDU sessions, would trigger through an external enrichment server dynamic allocation taken, for example, away from the school PDU sessions, allocating them to the hospital. All that is possible with the RIC. In summary, Juniper's focus on the RIC and the end-to-end network slicing can be summarized here in these 4 broad categories. Open, we're driving for open and interoperable RIC platform. And we're happy today to claim that we are working with partners, onboarding their xApps on our RIC platform, in addition to building our own xApps and our apps, leveraging AI-driven enterprise experience, addressing user experience at the very core, and network efficiencies, leveraging AI. Juniper has a long tradition in this space and a singular focus on AI-driven enterprise using the MIST and the Marvis AI engine, which is being integrated in our radio intelligent controlling platform. Oran Alliance leadership is key, not just for Juniper, but for all the technology vendors and the operators. Paco is one of the leaders and contributors in the Oran community, as Vodafone in general, many other operators. Obviously, we at Juniper chair the network slicing task group, no surprise there, as well as co-chair the use case task group. And we are a major contributor, perhaps one of the top contributors in the Oran community. We have participation in pretty much all of the working groups. Finally, a key focus for us is the end-to-end network slice orchestration. And again, I cannot emphasize enough the importance of taking the power of the rig on the radio, the programmable radio, and stretching that capability to deliver end-to-end network slice with strong SLA guarantees, right? And that involves the ability to enforce the SLA across several transport domains, as well as several clouds that host parts of the packet core, as well as the data network that can be on the operator prem or in a public network. So we will switch to asking, using the benefit of having Paco with us, to find out a bit more about where his mind is and where Vodafone is heading. So Paco, would you be kind to share with us your views about adoption of the Oran architecture by Vodafone, and specifically, where do you see Vodafone being on the adoption side by, let's say, 2025, in the next 4 or 5 years?
That's a very good question. We are preparing ourselves to contribute more to the Oran Alliance and TIP. Yeah, I think it's very essential that some of the big players in the ecosystem help developing Open RAN in a collaborative manner. Even though we are a big player and we are putting resources, we cannot do this alone. So it's very important that some of us in the vendor community, in the operator community, we put all the focus. I think where we are in 2025 and beyond will be pretty much dependent on Open RAN getting to the right maturity, which I think it's going to happen. Also, it will depend on the adoption, the opportunities being out there, and we are already planning for more markets. We have trials in several countries with different suppliers, but this needs to happen also in other operators, not just us. And I think lately we have seen a lot of movement in the industry. We also need to see some of the innovations really getting there, the promises from Open RAN. So be it in the cost space or here in the radio intelligent controller application space, I think it's out of question that Open RAN is going to happen. The pace of it and exactly the adoption is still, I think, dependent on early success. So yeah, really looking forward to moving in the time machine to 2025 and seeing where we are. But I think it's going to be a big and big opportunity for Open RAN.
Thank you, Paco. How do you see network slicing? When we get to the point where we really can deliver network slicing in an end-to-end fashion, of course, with the rig playing a key role on the radio, do you see network slicing being part of your strategy for offering private mobile network services? Do you think that is going to play a role at Vodafone? What's your perspective?
Yeah, I think there is no doubt in that. We used to try and implement similar ideas to slicing in the past, even in 4G and before, but it's now with 5G that this is really possible. And I think what we see with the rig is an opportunity to take this to an extreme and have no limits on what you can do, right? So yeah, I think it's gonna be happening. I think if we are fair, I think that today there is still a little bit of work being done on the actual use cases, and some of them are clear, some of them are not. But I think the foundation and the flexibility that's required is going to be there, and for sure it will be used. Sometimes you develop a basic functionality or flexibility option, and then it is used later. We have seen that in many technological breakthroughs, right?
Yeah, that's that makes a lot of sense. I agree. You know, I've been accused of being focusing too much on network slicing, which is really, you know, I take the accusation, you know, guilty as charged. So going back to network slicing, I would love to have a crystal ball and try to see when operators are going to start adopting network slicing. But let me ask the question, you know, in a simpler form. What's your opinion about when network slicing is going to become a must-have in 5G networks? And initially, it may be only on those 3 slices that you know 3GPP has essentially mandated: the URLLC, the enhanced mobile broadband, and the machine-to-machine, right? But there are opportunities for in between. But do you see any of them becoming sort of a mandate in the networks, and if so, by when?
I think the market will dictate. So as long as we see opportunities and you know commercial rollouts, then that will trigger and will be the foundation for that you know capability being implemented and as a must, right? So when this is going to happen, in a year maybe. I would say not way more than that. I think it's we are seeing 5G rollouts happening more and more. The development and deployment of standalone networks and the full 5G is becoming available, and as such, you know, slicing will happen. So I'd say a year, no more than that.
That's music to my ears, and I'm sure to the ears of many of our attendees. Finally, Paco, how, you know, for many of these, you know, forward-looking capabilities in the network, it's going to take several, you know, technology vendors to work together, right? Speaking of network slicing, for example. And of course, operators are going to be the catalyst, the critical component in enforcing the hand of especially the large, you know, vendors to work with innovative, you know, companies in the space to really deliver this promise of software-driven everything, right, in 5G. Do you see operators like Vodafone, global, you know, tier 1 operators, becoming more active in forcing the hand of, you know, the large vendors to say, you know, you've got to work with XYZ to bring this value to me? You know?
Yeah, I mean, I see that happening, but my hope is that this becomes naturally the way of working. I think the new model is by default but by design is collaborative. So exactly. I hope that happens naturally and that we all find the right incentives to play.
And that's a high note to end our presentation. And that's definitely a great wish. Thank you so much, Paco. And thank you very much to all of the participants. We look forward to seeing you hopefully in the next, you know, the next time face to face, when our world will be in a better shape. Thank you again. Goodbye.
Thank you very much for having me. Thank you.